In this video I'm going to talk about projectiles, and essentially a projectile is just an object that's launched through the air. But the technical definition, the physics definition, is that a projectile is an object upon which gravity is the only force acting. Now that means one, air resistance is negligible. We can ignore it, or it's going to be very small. And two, usually when we analyze projectile motion, we're analyzing it near the surface of the Earth. That means the force of gravity is constant. We don't have to deal with Newton's law of universal gravitation. Now, if you've ever launched an object through the air, if you've ever thrown an object or seen a baseball hit, or really any object that's just straight up thrown, you'll probably recognize the shape of the trajectory. It looks like this. It is a parabolic arc. And it's always going to be that parabolic shape, always going to be a parabola. It has some sideways velocity that carries it to the right in this picture's case. And it has an initial upwards velocity, but gravity pulls it down, accelerates it down, so that it eventually slows to a stop at the peak in the vertical direction and then moves down. So let's use Newton's laws to figure out what's actually going to be going on with the projectile. So let's start with a free body diagram. If the only force acting on our projectile is gravity, then our free body diagram is pretty straightforward. It's just a downward force of gravity, and that force of gravity is going to be equal to mg. Now we can set up Newton's laws in the x and y direction. In the x direction, sum of the forces is equal to mass times acceleration in the x direction. That is the horizontal direction always for projectile motion. But there are no forces in the x direction, which means our acceleration is going to be equal to 0. A in the x direction is equal to 0, which means we have constant velocity motion in the horizontal direction. This is hugely important, and this is great. If we have constant velocity motion, then there's really only one equation that governs the kinematics of our motion, and that is our velocity in the x direction is equal to our displacement in the x direction over time. Speed is distance over time. Now, in the vertical direction, the y direction, we do have a force. So let's analyze the motion in the vertical direction. Vertical. Newton's second law says sum of the forces in the y direction equals mass times acceleration in the y direction. Our only force in the y direction is gravity. It points down. So mg is our force. That's equal to mass times our y acceleration. M's cancel on both sides, so we're left with our acceleration in the y direction is just equal to g. But g is a constant. So in the y direction, we have uniformly accelerated motion. Uniformly accelerated motion with an acceleration of g down. Now, if we have uniformly accelerated motion, we can just use our kinematics equations that we've always used. We're going to use them in the y direction. There are 5 possible kinematics equations, but I'm just going to write down the 3 most important. V final equals V initial plus AT. We know that displacement in the y direction is going to be V naught y times t plus 1/2 acceleration in the y direction, t squared. And then our time-independent equation is V final squared, it's V final y squared, equals V initial y squared plus 2ay times delta y. So we have 2 components of motion, each independent of one another, each with a different type of motion. And that independence is the really important takeaway here. The x direction moves independently of the y direction. And the only variable that's shared among x and y is time. So let's take a look at our motion in terms of the x and y motions. If our x motion is constant velocity, then we can kind of track the motion of this object. I'm going to draw dots to represent equal time intervals down here. Constant velocity motion means those dots are going to be evenly spaced. So we're going to get something like this in the x direction. Should be perfectly equally spaced, but maybe a little bit off. And in the vertical direction, we have uniformly accelerated motion, so we're going to get a parabola. I'm going to draw it over here. Our position is going to increase. First, it's going to be a high speed, then it's gradually going to get lower and lower and lower and lower over time. And this is the trajectory of an object with a constant acceleration in the downward direction with an initial upward velocity. We can also look at projectile motion in terms of vector components. Since we're only looking in the x and the y direction, we really only need to think about our x velocity vectors and our y velocity vectors. Now, we have some initial velocity v0, which means we can resolve our vector into components. This would be v0 y, and this would be v0 x. And actually, to make this easier, I'm going to move my v0 y over to a point on our trajectory. So it's actually right here, v0 y. And this is our total velocity v0. If we look at different times throughout the trajectory, let's look right here. The horizontal since the horizontal component of our vector is, our horizontal velocity is constant, our v0 x vector is going to be the same. And over time, our v0 y vector is going to get more negative. It's a negative acceleration. So vy here is going to be like this, and vx is going to be the same. At the very top of our trajectory, the vertical component is 0, so we only have our vx, vy equals 0. Then over here, vx is still the same value to the right. Vy is going to be down. Over here, vx is still constant to the right. Vy is down. And then at the very bottom, vx is still going to be constant to the right with the same magnitude. And vy is going to be at its maximum. So the essential idea here is that our x component is a constant velocity, our y component is uniformly accelerated motion. I know I'm repeating that a lot, but that's what makes projectiles, that's what makes it easy to analyze projectiles. So anytime we deal with a problem, a projectile situation, in order to figure out what's going on, we're going to break our situation up into x and y components. So for example, in this situation, we're given some initial x velocity and some initial y velocity. When we set up our problem solving, we're going to have a set of x variables, or horizontal variables, and we're going to have a set of y variables. In the x direction, we're going to have vx, which is constant. Your initial and final velocities are always the same. We're going to have displacement in the x direction, delta x, and we're going to have time. In the y direction, we're going to have, depending on what interval we're looking at, we're going to have our initial y velocity. Since our velocity is changing, we need an initial. We need a final velocity in the y direction. We need an acceleration in the y direction, which is always equal to g. If you say down is negative, then it's always going to be equal to negative g. So let's just say down is negative for the sake of this video. You're going to need a y displacement, delta y. It's your final minus your initial position in the y direction. And you need your time. Depending on which variables we have, we're going to use our kinematics equations in the x direction or in the y direction that we already discussed earlier to figure out the other variables. Now, the only other thing that's special about this is our x and y motions are independent, but because it's one motion, if we solve for time for one component, we figured out time for the other component. So we can go from one component to the other using our time variable. And that's essentially what projectile motion is. Object launched through the air. Gravity is our only force, which means we have a constant downward acceleration. In the horizontal direction, it's constant velocity motion, so we have velocity as distance over, or displacement over time. In the vertical direction, it's uniformly accelerated motion, so we use our uniformly accelerated motion kinematics equations. We set up our x and our y components, fill in our given variables, solve for unknowns, and use time to go from one variable to another. Hope this is helpful. Bye.